Welcome to Math 360, 1 at day 20. This is example 6. In this example, we're going to look at a random variable that is continuous with the PDF f of x is equal to x squared over 3 on the support of -1 to 2. And so as we consider this particular random variable and this particular distribution, we want to know what would the distribution be of a random variable y, which is equal to our random variable x being squared. What would the PDF of that variable be? And so, as we start to determine that, we want to look at the support of y and define the support of y as between 0 and 4 with the careful observation of du cy. Y is the support of this random variable. And we can expand a little bit further and noting that for the interval from a 0 to 1 for y, the transformation itself is a 2 to 1 transformation. So kind of visualize why that may be the case. Consider the following graphic here. And so here's the graph of sketch of this PDF from this blue x squared over 3. You can see the horizontal lines corresponding to y equals 0 and y equals 1. You're going to see that the support of x between -1 and 1 gets folded into the interval from 0 to 1 for y. And so you get two branches of this relationship. So x1 is going to equal to the negative square root of y, which is going to go from -1 to 0. And then x2 is going to go from 0 to 1. So 1 would be this branch. And maybe I should have colored them two different branches. That would have been a better visual. But you can see then that the transformation itself corresponds to a case when our value gets repeated. And so if we consider this result from 1 to 4, then x2 is 1 to 1 on the interval from 1 to 2. And so for x2, and so we're looking at the derivatives for dx1 dy, you get -1 over 2 square roots of y. And for dx2 dy, you get 1 over the square root of y, 1/2 the square root of y. And so those are the corresponding derivatives for this function. Okay, and for this transformation, which according to our theorem, gives us then the values for the appropriateness of this. And so finally, we consider the PDF of y then. We'll call it g of y, since f was taken by the distribution, the PDF of x. And so we plug this in. And so you get then that the square root of -y, this is for x1, squared over 3 times the derivative, plus then for x2, the square root of y squared over 3 times the derivative, so that's the value of the derivative 1 over 2 square roots of y. Gives us then for the 2 to 1 branch a square root of y over 3 for 0 to 1 for y. And then correspondingly, we get the transformation then for y on the branch from 1 to 4 is simplifies to the square root of y over 6. And so finally, now that we have the PDF, it just is important to revisit or re-explore the idea that on the values from 0 to 1, the PDF is the sum of two terms corresponding to the 2 to 1 transformation, and on the interval from 1 to 4, it corresponds to a 1 to 1 on that branch. Okay, all right, I hope that was helpful, and I'll see you in the next video.